Welcome to the Deep Dive, where we unpack complex topics and pull out the insights you can actually use. And for this deep dive, a special welcome to the Arkaro Insights podcast. Our goal here is simple: help B2B execs like you get better results using the latest thinking on change and innovation. Today, we're tackling something critical, a stage where so many great ideas just stumble: prototyping and testing.
That's exactly right. It's its pivotal moment. You can have a brilliant concept, technically sound on paper, but this is where it often falls apart before ever hitting the market. It's really the moment of truth, where the theory meets, well, reality, where the rubber hits the road.
Yeah, absolutely. And we're drawing our insights today from a really sharp article by Mark Blackwell, who's the founder of Arkaro. It's called The Prototyping Trap: How Testing Failures Destroy Product Launches. That's actually part of an 8-part series he did on the hidden reasons product launches fail. Really fascinating stuff. So our mission today: unpack the 3 big failure modes in this stage, and then most importantly, look at how the successful companies get through this, this tricky phase and actually launch things that work and thrive. Okay, let's dig in.
So when we talk prototyping and testing, it's a real shift, right? Before this, teams are maybe focused on market research, value props, business models, that kind of thing.
Yeah.
But now it flips. They have to create something tangible, a physical product, software, maybe a complex system, something customers can actually touch, use, test out.
It's that jump from just an idea to something real.
Exactly, from concept to a functional reality.
And it's right there at that exact point we see some, frankly, spectacular failures. I mean, think about Juicero. They raised, $120 million for a $400 juicer. And technically, it was impressive. The engineering was solid. The prototypes worked perfectly.
Oh, yeah, technically flawless. But the amazing thing, the real aha moment, came from that Bloomberg piece, remember? It showed people could get the exact same result just by squeezing the juice packets by hand.
By hand.
Yeah. So it wasn't a technical failure at all. The machine did what it was supposed to do, but it showed this massive misunderstanding of customer value. They solved this really complex engineering puzzle.
But nobody actually had.
Exactly. Or at least nobody valued the solution at $400.
And then you contrast that with, say, Theranos. Over $700 million raised, this revolutionary blood testing idea. We all know how that ended.
Right. And that was almost the mirror image problem, wasn't it? The FDA reports came out later and basically said the Edison device just couldn't do what they promised. Not in the real world. It was a fundamental breakdown in functionality, a complete failure to deliver on the core promise, despite all the hype, all the money.
So 2 massive failures, both happening in that prototyping phase, but for totally different reasons. One built something amazing but pointless. The other promised the moon and, well, couldn't deliver.
Precisely. Understanding these different ways things can go wrong is it's essential.
Absolutely crucial if you want to launch successfully.
Yeah, and looking at lots of cases, including our work with clients in ag, food, chemicals, we see these patterns again and again. We've really boiled it down to 3 main failure modes that just keep popping up. Knowing them is step 1 to avoiding them.
Okay, so let's break them down. What's the very first trap? The first way companies stumble here?
The first one we call technical over-delivery. This is where companies get really good at the engineering. They invest a ton in sophisticated solutions. But the customers, they just don't value that sophistication enough to pay for it or deal with the complexity. It's like engineering brilliance pointed in the wrong direction.
The sophisticated solution trap. Juicero is the perfect example, like we said. It wasn't just a juicer. It was this incredibly complicated piece of engineering built like something for a restaurant kitchen, not a home countertop. Wi-Fi, apps, QR codes.
All that tech.
Yeah, all this amazing tech. And it just hid the simple fact you could squeeze the packet yourself. They used really expensive, complex tech to solve a problem that wasn't really there.
And Juicero isn't alone. Think about Google Glass. Technically, amazing.
Yeah.
Lightweight, the display, the connectivity.
Super cool tech.
Definitely. But the prototyping just didn't prove that people actually needed or wanted that in their daily lives. Not beyond a tiny niche anyway. Or the Segway. Remember the Segway? Breakthrough gyroscopic tech, self-balancing. Incredible stuff.
Yeah, really cool.
But it solved a transportation problem that, for most people, wasn't a high priority, especially not at that price.
It really makes you wonder, how does so much smart engineering go so wrong? It sounds like that innovation paradox you mentioned. The more complex you make it, the bigger the risk you're solving a non-problem.
That's a great way to put it. It captures it perfectly. What happens is the technical teams, understandably, get excited by the challenge. They can become more focused on the excitement of the technical challenge than the actual users.
Mm-hmm.
And that can create this sort of echo chamber. Everyone internally is impressed with the tech, but they lose sight of what the customer actually needs or values.
That's such a critical point.
Yeah.
It's not just, does it work, but does it work in a way the customer cares about? Quite. Okay, so that leads us nicely into the second failure mode, technical under delivery. This is basically the opposite, right? Failing on your promises.
Exactly. This happens when the prototype or the final tech just fails to deliver what was promised, especially under real-world conditions. And this often comes down to cutting corners, maybe poor quality control, or just not testing rigorously enough to find the flaws early on.
Right. And you mentioned flawed testing methodologies here.
Mhm.
New Coke is fascinating. They did, what, over 200,000 taste tests?
Yeah, a huge number.
Sounds incredibly thorough for testing a new product. So how did that still go so wrong?
Well, the interesting thing, the trap there, was that they tested only for taste. They optimized for that one technical thing, flavor preference, but they completely missed the emotional connection, the cultural significance of Coke, that deep brand loyalty.
So the product worked in the narrow sense of the taste test.
Right. Technically, it won on taste preference in those specific tests,
Right.
but the testing missed the whole customer experience, the meaning of the brand.
And looking bigger, you mentioned Monsanto's Roundup Ready crops. Their models looked okay in the lab, right?
Yeah. In controlled tests, the predictive models for managing weed resistance seemed solid. But out in the real world, in diverse farming systems, they just didn't hold up. The tech overestimated how long the glyphosate herbicide would actually work against weeds, and it totally failed to predict how quickly resistance would evolve. We're talking over 50 weed species developing resistance.
Wow. That's technical underdelivery with massive consequences, where the sophisticated models just couldn't cope with real-world messiness.
Precisely. And, well, back to Theranos. We keep mentioning them, but it's such a stark case. The Edison device flat out didn't work as advertised. The FDA reports showed systematic failures. Things that rigorous prototyping should have caught much, much earlier. It wasn't just difficult. It was fundamentally non-functional for its claimed purpose.
Just didn't work. Plain and simple.
Hmm.
Okay, so those are really clear examples of prototypes just not living up to the hype or the basic requirements. That brings us to the third critical failure mode, inadequate risk identification, missing the downsides.
This is a big one. It happens when companies are maybe rushing, feeling pressure to launch, and they don't adequately test for potential risks. They get focused on the upside, the potential success, and they neglect testing for the downside scenarios. The testing ends up being too superficial.
And the Starlink corn example you gave is pretty shocking here. It was meant for animal feed, pushed out quickly, but ended up contaminating the human food supply. How did testing miss that?
Well, that really raises a critical question, doesn't it? Aventis, the company, even had survey data showing farmers were already selling it for food. They submitted that data to the EPA but didn't put extra safeguards in place. And their plan to prevent contamination, these 660-foot buffer strips between fields, they just weren't enough. Wind blew the pollen, contaminated conventional corn.
And the result?
Huge contamination, maybe 50% of the U.S. corn supply affected. Over 300 food recalls, cost Aventis up to $1 billion.
Wow.
So the core tech for animal feed might have worked, but the process, the testing around it, completely failed to manage the contamination risk in the real world.
And it's not just bioag stuff. You mentioned John Deere's brake linkage issues, 2017 to 2024, similar pattern.
Very similar. The equipment worked okay under standard, maybe ideal conditions, but out in the diverse, messy, real-world farm conditions, they failed. It highlights that gap again. Testing protocols validated performance in the lab or under ideal settings, but they completely missed how things would fail under stress or in edge cases.
That sounds exactly like the speed versus rigor trade-off you talked about.
It is. Organizations feel that pressure, commercial pressure usually, to speed up development. So they cut corners on validation, they make assumptions, they focus testing only on proving it works, not exploring how it might fail, and that gamble can backfire spectacularly.
Okay, so those are the three big traps: technical overdelivery, technical underdelivery, and inadequate risk identification. Building the wrong thing, building it badly, or missing the dangers. So if those are the pitfalls, how do companies actually get this right? What's the path forward to build better prototyping and testing?
Well, understanding these failure modes is really the crucial first step because it points the way. The companies that succeed consistently, they don't just check if the product works. They validate three things: Does it solve the right problem for the customer? Does it actually deliver on its promises reliably? And crucially, will it create unexpected risks when it's out there in the real world at scale?
And Arcaro's identified 5 key practices, right, from clients who seem to nail this consistently. What's number 1?
Number one is fundamental. Validate customer value before technical development. Get customers involved super early. Define success through their eyes. Make sure your whole development effort is focused on real market needs, not just cool tech problems or what you assume they want. That's how you avoid being the next Juicero or Google Glass.
Makes sense. Solve the right problem first. Okay, so once you're sure about the problem, what's next? How do you avoid the Theranos or Monsanto situation?
That brings us to practice number two. Implement rigorous testing protocols and maintain them. You need comprehensive protocols that actually mirror real-world conditions, and you absolutely cannot compromise safety or quality just to go faster. Test the normal scenarios, yes, but also test the extremes, the edge cases. Be thorough.
Okay, thorough testing for functionality. But what about those hidden dangers? The new Coke cultural myths, the Starlink contamination.
That's practice number three. Test for downside risks and unintended consequences. Don't just look for the good stuff, the positive metrics you want to see. You have to systematically look for the negatives. Potential safety problems, weird side effects, unintended consequences go way beyond just checking if the tech works as designed.
It really sounds like this testing and validation isn't just a final gate you pass through before launch.
Absolutely not. And that's the fourth practice. Build continuous validation throughout development. You have to weave rigorous testing and customer feedback into the entire process, from early concepts right through why. Because you catch problems when they're still small, easy, and cheap to fix. You avoid those huge, expensive blow-ups late in the game.
That makes so much sense. Okay,
Good.
and the fifth practice. Sounds like it's more about culture, maybe mindset.
It absolutely is. Number 5 is create learning-oriented development cultures. It's about structuring your whole process to maximize learning about customer needs, market realities, technical limits, potential risks. Move away from just pass-fail testing. Create an environment, psychological safety, where teams feel okay admitting something isn't working and can pivot based on evidence, not just sticking to the original plan no matter what.
These 5 practices really tie it all together. And for you listening, this is where you can start thinking about your own organization. Ask yourself some tough questions. Do your testing protocols really match how customers use your product? Or are they just lab tests? How early do customers actually get their hands on prototypes and give feedback? Have you really mapped out all the different conditions, environment, usage your product will face? Do your manufacturing folks get involved early in prototyping or only see it when it's time to scale? And maybe most importantly, what do you actually learn from testing beyond just did it pass or fail?
Yeah, answering those questions honestly, that'll give you a pretty good sense of where you might be vulnerable to these kinds of expensive late-stage problems.
It's clear from this deep dive, isn't it? Technical brilliance alone just isn't enough. The real test is whether your innovation can actually meet the market, solve a real problem, deliver on its promises, and do it safely, without those unexpected stumbles.
It makes you think, doesn't it? What if the biggest risk for your next big idea isn't some technical hurdle you haven't figured out yet? What if the real risk is that you haven't truly understood the problem you're solving, or the promise you're making, or the messy reality your product is about to enter? That's something to really mull over.
Definitely something to think about. Well, thank you for joining us for this deep dive on prototyping and testing. As we've heard, getting this stage right is just absolutely essential for B2B leaders aiming for better results and successful innovation. Now, Arkaro specializes in exactly these areas: strategy, innovation process, product management, commercial excellence, and business development. They work closely with clients, particularly in agriculture, food, and chemicals, using a very collaborative, do-it-with-you approach to build solutions that really stick and create value. So if you're thinking it's time to strengthen your own prototyping and testing processes, you can learn more about Arkaro's services by visiting arkaro.com. That's arkaro.kr.com, or find Arkaro on LinkedIn. And if you'd like a free consultation to discuss your specific challenges, you can email Mark Blackwell directly. His email is mark@arkaro.com. Thank you again for listening to the Arkaro Insights podcast. And if you found this deep dive helpful, please do share it with your colleagues.